All right, so we're going to take on part 2 here of our lesson dealing with inequalities. And we're going to start with this equation here. 3x minus 5y is less or equal to 15. Now we want to graph this and then shade which way is the correct way for this graph. And the easiest way to start out by doing that is find our x and y intercepts. So let's go ahead and make a little table here. Let's get a couple of points so we know how to graph this. We'll start out with saying our y-intercept, and we'll go ahead and say our x is 0, because across this y-axis here, x has to equal 0. So if we do that, we'll go ahead and say we have 3 times 0, because our place for x is 0, minus 5y. And in this case, we're not going to worry about the inequality symbol there. We're going to say equals 15, because we're solving for a value of y. So it's equals 15 to start out with. So we want to find what that y value is. Well, 3 times 0, of course, is 0, so that goes away, and we're left with negative 5y equals 15. All right, then we're going to divide by negative 5 on both sides. Goes away, we're left with y equals 15 divided by negative 5 is negative 3. So we have a negative 3. Okay, and then we're going to want to put in, to find our x-intercept, we're going to put a y as a 0. And we're going to find our x-intercept. So let's do that. So we were to take this same equation, and we're going to say 3x minus 5 times 0 is equal to 15. So we're just solving for x, so no reason to worry about the inequality symbols. And then 5 times 0, well, we'll have a 3x. And then a negative 5 times 0 just goes away to 0, so that goes away. And that equals 15. Then we're going to divide by 3. In which case we have x, those 3's go away, x is equal to 15 divided by 3 is 5. Okay, so now we've got x is 5 and 0. Well, let's go ahead and graph those 2 points. So I have 0 and negative 3, so 0 and then 1, 2, 3. That point right there. And then our graph doesn't quite go all the way out to 5. So we're going to do a little something different here. Make it go out to 5 a little bit. So we'll make this go out. We'll say that's 5 right there. Okay? So we will put our dot at 5 and 0. Put a dot right there. Now, we've got 2 dots on our graph, and we can go ahead and draw our line to connect it. Now, we're talking about what we dealt with in part 1 of the lesson. If we have a less than or equal to or greater than equal to, we should have a solid line. So with this one, we should have a solid line that connects these 2 points, in which case you can just put a line that goes on forever in either direction. So now we need to test a point from either side of this to see what's going to go on. So I'm going to go ahead and take, for one test point, let's see, we'll use blue. I'll take one test point of 0, 0. Let's see if that works. So if I was to put in 0, 0 here, so I was to put 0, 0. If I was to take this and say, put test points. So say 3 times 0 minus 5 times 0. And if that is less than or equal to 15, well, we have 0 minus 0 less than or equal to 15. Well, that checks off, right? Because we have 0 is less than or equal to 15. And 0 is a smaller number than 15. So that works. So that looks good. Let's check one spot over here to see if it's bad. Let's go with 2 and negative 3. So we'll say this is 2, negative 3. And we'll say we have 3 times 2 minus 5 times negative 3 less than or equal to 15. So we give us 6 minus, and we have 5 times a negative 3, which is a negative 15, less than or equal to 15. So we can rewrite this to get rid of all these negative signs and say 6 plus 15 is less than or equal to 15. Well, we can already tell that's not going to work out, right? Because that's going to give us 21 less than or equal to 15. Does that work? No, 21 is definitely greater than, so that's no good on that. So what that tells me is, since this 0, 0 point worked, then our shading should be up this way. We have a shade going this way on this graph, all right? That's what you're looking for. Now, another way you could have done this problem was, let's say you had this equation of 3x minus 5y is less than or equal to 15. Now you could have done it this way, and you could have solved for y, okay, to begin with. So let's do that. So we're going to take this, let's get y by itself. So subtract 3x from both sides. So we'll go away on this side, left with negative 5y less than or equal to 15 minus 3x. And then when we need to divide by negative 5, okay? Now the big trick with that is, when you divide by negative 5, this guy is going to flip. The sign will flip when you divide by a negative. So when you divide by this negative, negative 5's over there are going to go away, and you're left with y. And now instead of less than, you say greater than or equal to. And if we take 15 divided by negative 5 minus 3x over negative 5. So we should get y is greater than or equal to 15 divided by negative 5 is negative 3. And then we have a negative here. We'll get that positive 3/5 x. And I'm going to write this again just in the proper order. I like to write mx plus b. So your slope, x, and then negative 3 is your y-intercept. So in which case, we knew that, right, from our initial problem, because we knew the y-intercept. When we got here, we knew when x is 0, we knew that we would get negative 3. We knew that. So it should have worked out that way, in which case it did. We still had a negative 3. So at 0 and negative 3, we have the same point. And like we said, up 3 and over 5. And that put us at that point over here at 5. So we would have got the same line. It's a solid line. I know that's not the straightest line ever. Sorry about that. And with this too, you would still get the shading the same way as well. You can think of this another way, right? It says the y values are greater than or equal to this equation for the linear line. So for this, we're going to go ahead and say, for this setup here, we're going to say that we have a y value is greater than this. So in other words, saying your y values that are greater than. So if we pick a point over here, it should work to get our shading that way, just be simply because it says greater than. Now the greater than equal to determines the line, whether it be dashed or solid, which we already figured out because it's greater than or equal to is solid. But because it's showing that the greater than sign is saying the y values are greater than, well, we intercepted the y-axis at -3. So if I did the y value is 0, that's greater than -3. So that works out, right? Because 0 is greater than -3. So another way to think about it is going forward with it. All right, guys, so that's pretty much it for this lesson here, talking about that, dealing with standard form and graphing these guys. So I got 2 check your understanding problems for you to work out with that. Hope this made a little more sense. I'll see you next time.